Hey, hello there, and welcome back for more Advent of Code. So today is December 4th, and we are keeping up with daily puzzles, so let's just jump into it, and if I have the correct focus on the window, see what's going on. Oh, look at this. So day 4 we are jumping ahead. Quite a few lines here. I guess the gondola is taking us up. Interesting, I don't remember this happening in previous Advent of Codes. Where is it that these events, we can see the previous ones. Like last year, yeah, they were all in order, I think. The previous one, yeah, this one was the submarine one. Also in order, but going from the top to the bottom. 2020. Oh, look at this. In 2020, there was some jumping around. Yeah, I seem to remember this, that, you know, you went all around the place on a boat or something. And here it jumps from 8 to 9, and then 10, where is it? Like here. Okay, so this one did jump around in order. Interesting. I didn't remember that. I do remember that finding this monster was very difficult. Okay, so day 4. Scratch cards. What are scratch cards? Are they like punch cards or something? Punching, scratching, I guess it's sort of a violent thing to do to a card. Okay, so what is this about? The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You are not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of a new island and lurches into the station. Oh, cool. So we are not up a mountain, we are like in 2 floating islands, and we are going from one to the other. That's really cool. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Like, what is this, Buenos Aires? Is this where the water source is? Exactly. The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello. The elf excitedly runs over you. How may I be of service? You ask about water sources. I'm not sure. I just operated the gondola lift. That does sound like something we'd have, though. This is Island, after all. Island. Is this like a recursive kind of thing? I bet the gardener will know. He's on a different island, though. The smile kind surrounded by water, not the floating kind. Oh, okay, so this island has islands of water inside of it. Weird. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch pads as a gift, but I can't figure out what I've won. So what is a scratch pad? Scratch card? Oh, it is this thing from like this thing from the movie Charlie and the Chocolate Factory. Yeah, that you can scratch and win something. Yeah, that sounds right. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards. I have trouble pronouncing that. All with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. Okay, so we can see kind of the input here. A list of winning numbers and then a list of numbers you have. Okay. You organize the information into a table, your puzzle inputs. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. So for example, this is example input. In the above example, card 1 has 5 winning numbers, 41, 48, well, okay, yes, it's the numbers on the left, and 8 numbers you have. Of the numbers you have, 4 of them are winning numbers. Okay, so 48 is in the numbers you have, and it is on the winning numbers. Great. That means card 1 is worth 8 points. Okay, yeah, 2 to the power of 4. 1 for the first match, then double 3 times for each of the 3 matches after the first. Okay. Card 2 has 2 winning numbers, so it's worth 2 points. Card 3 has 2 winning numbers, again 2 points. Card 4 has 1 winning number, 84. Card 5 has no winning numbers, so it's worth no points. Okay. So in this example, the elf's pile of scratch pads is worth 13 points. Take a seat in the large pile of colorful cards. How many points are there worth in total? Okay. Interesting. So we have to, this seems pretty straightforward. We have to calculate which of these numbers are among these, and then do that, do 2 to the power of that number, or -1, I guess, something like that, or like start with 1 and multiply it. I guess we could do like a bit shift or something. But yeah, this seems pretty straightforward, I think, compared to the previous 2 days. So that is famous last words. Let's also increase the font size here. Oops, code. Also increase this font size. Oh, by the way, I added a couple of scripts to check, like to run all the samples that we have and check their output against their expected output. Then they have this nice colorful output, and also even check all of the real inputs. And I'm storing the inputs in an answers file. So this is what running all days outputs. So I can also run all. So yeah, I had some fun doing some shell scripting to have all of this. You can see that where is it? Check samples. There's a very ugly set expression here to extract numbers and things like that. But yeah, I like this kind of output with colors than in this horrible way of using escape codes. Yeah, I could have done these scripts in Rust, I guess, but Bash was sort of, I don't know, a simpler go-to language for this. And it is what Bash is good at, I guess. So let's do day 4. Copy the templates as usual. This is day 4. Scratch cards. Yeah. And let's copy the templates for the inputs. We are gonna have, oh, by the way, how does the actual input look like? Okay, so the cards are similar, just have more numbers, but this is not an enormous amount of numbers. I guess we can even get away with using linear search probably. So the real input is this. The sample inputs will be, let's close this, it's going to be this thing. Could probably automate this, but I don't care that much. And the output that we have for these cards for part 1 is 13. All right. So let's open this source file and close everything else. Close the sidebar, increase the font size. And okay, what should we do here? I'm tempted to just go ahead and implement this just in a single loop and not care about like modeling this on types or things like that. At least part one seems simple enough. So let's score sum b. What is this going to be? Well, we're gonna get the input separated in lines. We're gonna map each line to their what? Score, and then we are gonna sum all scores, I guess. We could probably have some failures while parsing, so I guess we could we could have the cards, I guess, first. And we're gonna do something like, map these things could fail, and then there is a try collect method that we can use that is just the same as collecting to a result, but this is this try collect comes from iter tools, and I added this dependency only for this method, because otherwise you had to do like collect into and specify here with this turbofish kind of thing, collect this into a result, and then like only to short circuit with question mark operator. But try collect basically is an alias for that, and it's pretty useful. So we're gonna have that, and then let's say let's score sum. Is it gonna be, well, it's gonna be, I don't know, U32, and it's gonna be cards. We're gonna iterate over them and map them to card score, let's say, and sum. Okay, so this is the high-level version of this. How do we parse each card? I think it should be fairly straightforward. We are going to, let's see. We don't care about the number of the card. I guess we are going to care about that in part 2, most likely. But we can split by this and then have these two lists of numbers. And split by this and then just parse every number or something like that. So, line. We want to have, what do we want to have? Like a left part with that we don't care about, and then we're gonna have just numbers part. And this is line split once by colon space. This could fail, and I want, in case it fails, I want to propagate up the error. So, okay, or malformed line, card line, let's say. I'm gonna short circuit this, and then we're gonna split again, and we're gonna have the winning numbers and my numbers, and we are going to once again split, no, not split that, split once, but this time with pipe, and again say, well, we're gonna say the same thing. Okay, that makes the line go over. This doesn't like this because can abuse that returns a result. Yes, this will return a result, don't worry. And then we have the winning numbers and my numbers, but they are strings, so we need to, well, I'm going to just winning numbers. So what are cards going to be? I think they are just going to be a tuple of two vectors with the winning numbers and the my numbers. So winning numbers is going to be also a vector of, let's say, U32. And this is going to be winning numbers. Actually, you know what? I want to call this like left numbers and right numbers. And then we're going to give it like, because just to name them how they are on the card, and then we are going to give them more meaning, like the winning numbers are the left numbers, something like that. So left numbers split, we can split by white space, I guess, or just use space character there. And we are going to map each of the numbers with what? I guess we can say stir parse. Are you gonna like that? I'm not sure if you will. And then we are going to, oh yes, we need to do the try collect trick again. So these are the winning numbers, and then we're gonna have my numbers, okay, and then in the end we're gonna say okay with a tuple of winning numbers and my numbers. Are you happy with this? Yes. Rust is happy about all of these error coercions and things. That's awesome. I'm not entirely happy though. I usually separate this parsing things into functions, so let's actually do that. This is gonna be parse card, and it inferred the result type correctly, but not the error types. Let's use the powerful boxed dynamic error. That's great. Okay, and we can remove this closure here. Great. We do have the cards. I think this code should work, but let's check this. Cards, and we're just gonna print cards like this. Oh, look at this, I made a mistake here. So I'm splitting the line. Again, this should be the numbers part, and then we have let's call it just left and right. And here we need to use the right. So thanks compiler for letting me know about unused variables. I had made 2 bugs in that little function. So we're gonna run what is this, day 4 scratch cards with inputs for sample. What? Parse int error kind empty. Interesting. So okay, we did have an error propagated up. So we are probably making we are splitting by space, and we probably have like 2 spaces here. That's an assumption that we shouldn't be making. So let's do, instead of this split by a single space, let's say split white space, and that's it. Yeah, that's it. Yeah, and now it parses correctly. I cannot trust these numbers. They seem all right. Yeah, they do seem like they are what we want. So now let's calculate the score sum. We need to calculate the score of each card. So, well, the rational analyzer is not so intelligent as to define functions given this map usage here. So here we're going to take the two cards. No, sorry, take a single card, right? Yes. So, well, a card will have winning numbers and my numbers. And this is gonna be a tuple. Well, it's gonna be this basically. Although we probably want to take this by reference, right? And it's gonna return a U32. Would you be happy with this? Yes, the types are correct. Now, how do we do this? Well, we want to find which numbers of my numbers are winning numbers. So it's basically the intersection, I guess, in between two sets. I'm wondering if I should have used hash sets for this, maybe. Does hash set have a method of intersection? Yes, it does. We don't care though about which numbers they are. We just care about their count. So yeah, let's just say let's count, and we're gonna have how many. Yeah, we're gonna count how many winning numbers we have. So my numbers. We're gonna iterate, and we are going to map. Oh, I think we do have a lot of more now counts. I think this extra functions probably come from iter tools, right? Yes, I didn't know about these things, but what I want to do is like, okay, filter and then count. That's what I want. And we want to filter my numbers like that appear in the winning numbers. So winning numbers contains my number. Yes. Okay. Does this make you happy? Yes. So if the count is 0, we return 0. Otherwise, what do we do? I don't know if we can generalize that, or we have to do like if count is 0. I think I want to do this. Return 0. Otherwise, we're going to return 1 shifted by count minus 1, I think. So if it's only one winning number, it is going to be 1 shifted by 0, so it's 1. If it's 2 winning numbers, it's 1 shifted by 1, so it's 2, and so on. If it is 4 winning numbers, like the example, it's going to be 1 shifted by 3, which should be 2 Yeah, we went shift by 3, sorry, 2, 4, 8, so it makes sense. Okay, so that's it. Let's see if not using hash sets makes sense. We're going to just print the score sum. And let's run this. Expected. Oh, my face is on the way. Oh, I think I left this. And sure, let's run again. 13. Yeah, that is what we wanted for the sample. So let's run this with the input. And it's 22,000 and something. Let's try this out. And yeah, that was the correct answer. Awesome. So part 1 was relatively quite straightforward, I would say. If you care about algorithmic complexity, you're probably cringing about this quadratic thing here, because we are iterating over. Where is this? No, not this. Here, to calculate the score sum, we are iterating over all the cards and calculating the card score. Sorry, and for each card, the card score is quadratic, because we are iterating all the my numbers, and then for each one, we are iterating linearly over all the winning numbers. This could have been done in linear time instead of quadratic, by using hash sets, or maybe binaries, like sorted vectors, and then using binary search. But you know, these cards are pretty small, so linear search can be fine. Yeah, I do wonder if I could write this as an if else, something like this. Yeah, and I don't know if I can generalize this. Don't think so. No, I think it probably can, but I cannot come up with an expression that, you know, gives you 0 for 0 and then this thing for positive numbers. So okay, let's take a look at part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There is no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have. Okay. Win more scratch cards. Specifically, you win copies of the scratch cards below the winning card, equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win one copy. Each of cards 11, 12, okay, up to 15. One copy each. Okay, I didn't really understand that. Copies of scratch cards are scored like normal scratch cards and have the same card number. Okay, so copies. As the cards they copied have the same card numbers. Okay, so if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. I'm not understanding this. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. So this sounds like a sort of explosive thing. I mean, it's day 4. Am I supposed to use dynamic programming already? This time the above example goes differently. So card 1 has 4 matching numbers. So you win 1 copy each of the next 4 cards. Cards 2, 3, 4, and 5. So you win 1 copy of this. So we are going to be copying these cards. Your original card 2 has 2 matching numbers, so you win 1 copy each of cards 3 and 4. Okay. Your copy of card 2 also wins 1 copy of each of cards 3 and 4. Okay. Your 4 instances of card 3, 1 original and 3 copies. Okay, so we did 3 copies because we copied 1 for card 1. Then we had 2 card 2s, and that made 2 copies more of card 3. Interesting. So we had 4 instances of card 3. Have 2 matching numbers, so you win 4 copies each of cards 4 and 5. Your 8 instances of card 4, 1 original and 7 copies, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, 1 original and 13 copies, have no matching numbers and win no more cards. Your 1 instance of card 6, the original has no matching numbers and wins no more cards. Okay. And you only have 1 instance of that. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 card 4, 14 card 5, and 1 instance of card 6. In total, this example pile of scratch cards causes you to ultimately have 13 scratch cards. Okay. Process all of the original and copied scratch cards until no more scratch cards are won, including the original set of scratch cards. How many total scratch cards do you need? Do you end up with? Okay, now things got complicated and quite interesting. So yeah, this really sounds like one of those dynamic programming things. One of those puzzles that can be very easily solvable with dynamic programming, and I suck at those. So okay, you have copies of cards. We are not keeping the numbers of these cards, but we can use the indices that they have on the cards vector. So there are indices on this thing. So first of all, let's add all of this. Maybe I also want to check all. Oh, I need to generate the, it failed. You can see that it failed on checking the answers txt. So maybe let's add that answer. We can say run all and put this on answers txt. And now if we check all, oops, sorry. Yes, no, I just run all again. Let's check all. Okay. And we only have like part 1 for day 4, but that's fine. We can already commit this. Add day 4, part 1 solution. All right. So how do we go about this? Okay. we need to keep like the information of how many copies of each card we have. And I think we can keep that like on a separate vector, just the numbers corresponding to each, like how many we have of each card. Actually, this might not be as difficult, I think. Yeah. Let's just do the same thing that we did for part 1, but say card score part 2. Yeah. And this is gonna be part 1 score, and this is gonna be part 2 score. Okay. So, okay, no, it's not as simple as this, because we need to actually have we need to have all the cards when computing their scores, I think. So yeah, let's actually extract this into a function. Yeah, so this is gonna be part 2 part 2 score. And I think, does Rust has any problem with this? I'm not really sure. It's gonna be more complicated than part 1, for sure. But we are gonna use this card score for part 2 also. So I think I want to have, say, let mute, I want to have a vector of how many of each card we have. So let's say card copies. It's gonna be, well, initially we're gonna have 1 copy of each card, so it's gonna be this card's length. Okay. Actually, this I think should take, let's say, a slice of cards. And pass it like this. This probably merits sorry, this is parse card. Yeah, I think this thing wants to be let's say alias, let's say card. This takes a card, and yes, this takes a slice of cards. Great. So what are we going to do then? We want to go over each of the original cards, this thing, and calculate the score for each And then for each score, increment the amount of copies that we have of that card, I think. And of the next card, sorry. And with that, yeah, I think after that it's gonna be a matter of multiplying how many cards we have on each of these card copies, and how many, and what the score for that card. Right? I think so. Yeah. So we can probably do compute the card scores actually, sort of like this. Card copies, and we can say let card scores be a vector of the scores. And by the way, I don't know if U32 is gonna be enough, because this seems like a sort of combinatorial thing, so we might need bigger numbers. But yeah, card scores is gonna be cards, iterates, and actually, yeah, this thing, and collect into a vector. And I just saw that there was a collect vec that this probably comes from itertools. Yeah, interesting. Okay, I don't think I need to go for that. So we have now the scores of each card. What do we want to do with this? I think I want to say for each score, index and score, we are going to need the indices in card scores iter enumerate. What are we going to do? Well, for example, if the first card in this example has a score of 4, that means we're going to add 1 copy of each of these cards. And we are going to add only 1 copy because we have 1 copy of card 1. Then card 2, we have 2 copies of that. And that means, and I think that it had 2 winning numbers. So we are going to add 2 copies of 3 and 4 because we have 2 copies of card 2. Something like that seems sensible to me. Okay, so we are going to do something like let's like the count, or I don't know, copies, I don't know how to call this thing, but it's going to be card copies of I. So this is the amount of cards of each of this card itself, and we are going to do for, let's say, j starting in I plus 1, like the next card, and up to score, so up to I plus score, I think. Yes, does it make sense? So we're going to, for example, if we start at index 0, this gives us 4 winning numbers. So we're going to start at index 1, and up to index 4 included. Yeah, that makes sense. So for these indices, card copies of J, we're gonna add to them count times, no, just the count, how many of this we had. Stop complaining about this, please. And you don't like this because score is U32, fine, as U size. And you don't like this because score is a reference. Yeah, don't use a reference. I think that's sort of what we need. Let's print here, print line, copies, println, and this is card copies. How many card copies we have by the end? Index out of bounds. The length is, oh, I did it with the actual inputs. Okay. But we have a bug for sure. We run it with a sample and we have an infinite loop, it seems. Okay. Panicked. No, did we have an infinite loop? No, I just didn't hit enter, I think. Okay, we are indexing things out of bounds. Oh, no, because we are using the scores. We need to compute not the scores, but yeah, okay, that's different. But how many winning numbers are on each card? Okay, so that's sort of what we want to do. This is taking the card, so I'm going to just do this, and we can then. This is not card scores, is card wins, winning numbers, win count, yeah, something like that. And it's gonna be this calculation, and it's going to take basically this. So each card is going to have that. Beautiful. Win counts, and so it's not a score, it's a win count. Okay. Sure. It's already U size, so we don't need to do that. Okay. What happens now? Now it makes more sense. I think these numbers are similar to. Once all of the original copies have been processed, you end up with one instance of card 1. So 1, 2, 4, 8, 14, and 1. 1, 2, 4, 8, 14, and 1. Awesome. So we have the correct amount of copies. That's great. And now what we need to do is, I think, fairly straightforward. We are going to do so for each copy, yeah, we're gonna do cards. Is there a zip method here? No. Iter. Zip. card copies, we're gonna map this thing, and we're gonna have, well, the card itself and count, I guess, how many cards we have. And we are going to map to count times the card score for this card, and then we are going to sum all of this up, I think. What does this give us for the sample? 28, is this correct? That doesn't seem right, right? In total, this example pile of scratch cards causes you to ultimately have 30 scratches. No, you have to sum. Yeah, so only sum the copies. That's what we actually needed to do. So it's easier than this. Just say copies iter sum. Is this correct? 30, right? This is not the number that we want, I think. So with the actual input is this big number. Is this correct? Yeah. Okay, we only needed to compute the amount of cards for part 2. Great. So that wasn't that hard in the end. It didn't require, I think, I don't even know if this counts as doing dynamic programming. It's one of those names that I don't even understand why we call dynamic programming this idea. But yeah, this wasn't too hard. Let's, I think I forgot to, if we do a check all, we're gonna have some problems because, look at that output. So the sample doesn't match what we have, so we are missing a 30 here. So in sample out day 4, we also expect a 30, and then answers, we can regenerate those, and then if we check all, we have everything. Great. That's great. So card score. What can we do here? Maybe, like, this algorithm is quite okay, I think. The only thing that I would like to get rid of is like this repetition of counting how many winning numbers one card has. So, and I think that's the only case where we actually care about winning numbers. Yeah. We don't actually need the cards, I think. So we can just say something simpler here. So yeah, you know what? Let's first add this, and I want to just compute, like, we have each card, right? We are parsing those. Great. After parsing, we can just convert each line and get how many win like winning numbers that card has. And once we do that, it's like we don't even need to, parse the cards really, to be honest. And I'm almost tempted to do that. Parse card. Yeah, sure. Let's say let's simply win counts. It's gonna be just a vector, and this is gonna be cards iter map to something and collect, and that what we are mapping into, well, is basically this thing. So yeah, this closure. And then this part 1 and part 2 just, I think, need this win count. So for part 1, we can call this actually like total score, yes. Did this thing named it? Oh, let's take a look at the, look at the advent calendar now. We are in this second island. Awesome. How did this thing called, how many points are there worth in total? Okay, so points. Total points. So we're gonna do not map the cards themselves, but just map the win counts. And we're just simply going to do each win count. We're gonna do this. If the, we can even call it count. And we can add the reference here. Total points, great. And then for part 2, what we are calculating, and I think, yeah, now this is not used anymore. Great, goodbye. For part 2, we don't need to pass the cards. We can pass the win counts. And this will receive the win counts, and it's just going to be a slice of new size, I think. Yes. We don't need to do this. We can say win counts here. We can do this. And that's it, I think. Does this still give us the same answers? Yes, it does. And you know what? I feel kind of tempted to just inline this thing. Well, the inlining was not very nice. Let's move these card copies up. Yeah, we're going to compute these card copies, and part 2 is just going to be this thing, and it's not part 2 score, it's just total cards with the copies, basically. Okay. And this shall be the copies Yeah, it's just usize, I think. Great. So I think this is fine to have everything in the main. So yeah, extracting this, I think each part is pretty straightforward. So first, like maybe we could extract these. That is fine. How many of the winning numbers are in my numbers? Yeah, that's totally fine. And then, yes, we compute the part 1 answer, which is the total points, with this little calculation. Then we compute the card copies for part 2, which I think using a for loop like this is fine. Awesome. Count. I think we can probably inline this thing. Yeah. Better still. And that's it, I think. I don't think I want to touch anything else. Oh, yes, there is one little thing that I want to try, but let's first check that this all runs. Yes. I want to just quickly check if maybe using, oh, now this type doesn't make sense to have an alias for this thing. Can we inline this? Yeah, because we are not referring to cards all over the place, so that's great. If it makes sense to use hash sets in here, so hash sets, we are going to have everything else as this, but with that I think it could be like everything still compiles, and I think the answer should still be the same, and yes it is, but this could be just my numbers intersection with winning numbers, and just count this. Maybe that's nicer, and it's still the same result. That's great. I think that's fine if we say time. What do I want to do? Time the day 4 with inputs day 4 input blah blah. 4 milliseconds, that's more than fine. So, and I don't know how much of that time is initializing things. So I think, even though, I do prefer simple data structures like a vector over hash things, like in this case, given that our hash set provides this intersection, it lets us express things, I think, much more succinctly. So that's nice. Let's separate the parsing. Yeah, this all seems pretty good actually. I like this. And if we check all, we still have the same answers. That's great. Let's add this and commit and close all this gunk. So add solution for day 4 part 2. Yeah. Okay, that's, I think, everything that I want to do. Oh, I always forgetting to do one of the important things in these videos, which is to generate the thumbnail. So let's use our good old toilet. And what did we do today? This would be AOC day 4. Scratchpads. So no, scratch cards. Scratch cards. It's difficult to write these things. Oh, what about SM mono? Oh, look at that. And let's pass it to lolcat to see. Oof, that's awesome. Can we even like do this? No, that's not going to look nice. No. Forget about that. Let's make it. Whoa, what's happening? No, what happened with my face? Well, I hope you're still seeing my face. I lost track of that. But yeah, that's a good thumbnail, I think. This was day 4 of Advent of Code. If you have been watching, I hope you have enjoyed it. And I don't know, I like this day quite a bit. It was pretty straightforward, but I liked that part 2 seemed intimidating, but once you thought about it, it wasn't so intimidating. So it was actually nice. If you have been, thanks for watching and see you later. Bye bye.